Alright, welcome to the second video for Grasshopper in this workshop that we're doing. In this video I'm going to show you this exercise to create a shape that rotates. Each flow rotates independently. We started working on this in the last session, but I'm going to run a little bit more specifically into each one of the components that we use and how they work and how they interacting with each other. Something important to keep always in mind, I mentioned it in the first video, is to think in the logic that Grasshopper is using. Remember that it's always connecting data and making relationship between that information, those components, and the geometry that you create. So just something to keep in mind if when you download the case study exercise file from the Teams Microsoft Teams group, you're gonna find a lot of these groups that are for the next session, and we're gonna talk more about that. That is the more complex analysis test, that is with Ladybug and Galapagos, that we've talked a little bit about that. But we're going to focus in this part that is used creating the shape, creating the form, and creating the variables to manipulate that building. Okay, so let's start with the base geometry, and I'm actually going to turn everything off and turn it off on little by little. So as we did from the last video, working with that rectangle, very simple. What it is, you just give it a slider so I can move it from one dimension to another, making it all in millimeters. Then from that rectangle, what I wanted to do is to rotate that shape, and I created another slider. I will have to turn this on. There you go. And you can see what each one of these is doing. So I changed, like I said in the last session, when you use the rotate or anything that goes into angles, that uses angles and rotations, by default Grasshopper uses radians, but you can make it into degrees used by right clicking and degrees. Previous versions of Grasshopper and Rhino, I think from Rhino 6 onwards, it should work. If you don't see that option of degrees by right clicking, you can just search for degrees. You can use this component to do the same process, radians to degrees, and it will be easier to work with that. In here I just made that change from here. You can see that little icon. That just means that is degrees instead of radians. Okay, so how this rotate component works, that again, remember that you can just search double clicking and you find actually a lot of rotate options, rotation and rotate, and there's a lot of options, and each one of those have different changes. And sometimes it's really small changes. So keep in mind that there's a lot of components. Just keep a close eye on the information that it's asking you for. And I can show you here as a quick example. Here is actually to rotate a vector. And this one is to rotate a geometry, but it has some extra components. So also have the angle, but this one is asking for a center of rotation. And it will be different to this one that is asking for a plane of rotation. And you can experiment a little bit with those to see what they do and try to connect. Like you can see in that it has that X icon, so it's asking for a point that you can see in here on top. The X icon is a point, so you can connect any point in there. Try to connect multiple points and see what happens. And it's also asking for an axis, which you can see again with the icon, which it doesn't say what kind of information is requiring, but you can see by the icon that is that arrow. And again, you can go back into the parameters, basic parameters, and try to find out that the same icon, and you can see that this one is a vector, or as I show in the first video, you can also right click on top of the letters, extract parameter, and just Control-Alt click, and just it will take you where the information is, and you can just hover and see more about that. Also, right click into the components and right click into the components and go into help. Sometimes it's on top, but sometimes it's better just to go into the actual component and go to help. Any of those have the same, and you can find a lot more information. Sometimes not much more, but sometimes it is a good explanation. Okay, for this one I'm gonna use the plane, which is gonna use the center point, which I can also show you really quick. I'm gonna construct a point, which is x, y, z, which by default is in 0, 0, 0, and you can see here in the Rhino canvas that 0, 0, 0 is in there. This point, if I preview on, is at the center of the rectangle, which is the area component, which will give you the number, the area, and the centroid, which is a point, which is this one in the center. And let's see what happens when I connect this 0, as you can see, right in the corner instead of the center of the rectangle. All right, see what happened. It just goes right to that point. Basically what it's asking for is the center of this plane. The coordinates of this plane is going to be the center point of rotation. That way, if I use the center of the rectangle, that's why I got this little component, I can rotate it right in the same position and keep it center. And anything that I create on top of that, I can just follow along with that point, and everything is going to rotate. That's why it's important to have that center of rotation. Keep in mind what you're connecting. That's why you have to keep in mind what kind of plane, and also really important to keep in mind that here is asking for a plane, but I'm connecting a point, which is, it can be also confusing, but keep in mind that a point is actually a plane, because a plane is just coordinate system in x, y, z, and a point has a coordinate system that is x, y, z. That every time that you see a sequence of numbers like this with a little comma, most usually means that it's just the x, y, z coordinates. We plug in this to a plane. Wall x, y is simply 0, 0, 0. Anything that is wall x, y, x, z, y, z is, if it says wall, it's because it's in the 0, 0, 0 position. And if now I connect this to this one, let's see what happens. 5000 by 5000, which is the center of that rectangle. If I connect that to the plane, this is what happens. It will give you again the coordinates to create that plane, which is again 0, x, y, z. And this is specifying the angle, the vector of rotation, which is from the center upwards. That's why it's 1. We can go a little bit deeper in Cartesian planes. This is all geometry about Cartesian planes, and you can find a lot more information that explains it a lot better. Just Google it. But it's all about that x, y, z positioning. And vectors as well are x, y, z coordinates, but it just have a direction, like this z plus 1 or minus 1 is just the direction of those vectors. Now, a little bit confusing, but just try to follow the logic of what is asking you for and what you can do with those. And here the plane is just taking the center of that plane. Imagine this is this rectangle in here. Let's put it like this. Is x, y, and this is taking just the center of that x, y. Now, since I have that rotating, perfect. I'm going to go next to move it upwards, so I start to create the building. And I'm going to turn this off. And I'm going to move it up. So here is something that it might be confusing to understand right at the beginning, is how is it that I'm creating multiple things. And first of all, I'm using here the component move. And again, just go back into what it's asking you for. It's asking for a geometry, which geometry with that icon, that is the little spiral icon in black and white, is basically anything. You can put in any kind of geometry that you can create. Curve, cubes, polysurfaces, surfaces, anything. Pretty sure that you can put it in there. And then you have motion or translation vector, which again, as I mentioned, and you can see by the icon, the arrow, black and white arrow is a vector. It's just aligned with that direction, which normally means going from, again, Cartesian planes. If I plug this one is the vector. If I plug it in, it's just meaning the direction that is going. So X, Y, Z, always keep that in mind. Everything that is divided by that comma in three numbers is most often non-X, Y, Z. In this case, because I'm using the unit Z, the vector Z, which you can get by just typing X or Y or Z, you can get those default vectors. So always check for that arrow, and that's how you can make sure that you have the right one. If you press Y, you get the same arrow and going Y. Now let's connect this number that I have here, 2000. If I connect that one in here, now as you can see, the 2000 is in the middle, which is X, Y, Z. So that this is telling that take 0, 0 and move in the Y direction, in that direction, like looking like that, just in that direction, move 2000 units. And the same goes for X. It would just change to be X instead of Y. And if I put it in Z again, it's just going to be at the end. But now, little detail is how to make it move multiple things at the same time. So you don't have to duplicate the same move over and over and over. And that's when list come along. As you can see, I have here a series. And what a series that does is it takes, and you again always go to those start point letters and see what it's asking you for. And it's first number of series, then it asks you for a step, and then a count. So a series is basically a list of numbers, and you can tell it to start. By default is 0, which I leave it in default, so we can start in 0. Step is what is the amount of numbers that it will jump from number to number. In this case, because I connected 2000, so it's going to go 2000, 4000, 6000, etc., as you can see here. And count is just the number of elements that I want to create, which I said here I have 10, which I have here as the number of flows. And it will create then 10 elements. And something important to keep in mind in Grasshopper is that all the list, and actually in any computer programming software, is list start from 0. This is the index. Something important to differentiate. List have an index that is always going to be sequential from 0 to any number of elements that you have, and then the data contained within that list that is going to be at the right side. You always have that line separating those two. This is the index, this is the data. and the data can change and fluctuate, and you can edit that and manipulate it in any way that you want, but the index always have to go 0, 2, 3, 4, 5, 6 and so on. That cannot change. This is how lists work. They need to be in that way so the computers know what to take from the information. And here the count is going to be that amount of numbers, that amount of index that you're going to get. Because I gave it 10, it's going to count from 0 to 9. So 9 plus 0, which is going to be the 10th. And that's going to be really useful to keep in mind, because like is in this case, if I now connect this series, which is 0, 2000, so on to 18,000, to this one, see what happens. Now I'm going to place it side by side. What I'm doing here is telling the vector z to use each one of these numbers, and again keep really close attention to the index, because that's how Grasshopper is going to match the information between one component to the next. So in this case, because z is looking for a number to use into that z vector that is in here, it's going to take anything that you give it in a list, in a number that is in one list, to match it with the same index and put it in that z position. So 0 is going to start with 0, 1, 2000 goes to the 1, and z 2000, and just keep going like that, 2 to 2000. If I, for example, give it 3 elements to the count, now you have 3 elements, 0, 1, 2, and now you have the 0, 1, 2. Again, all the information is just flowing from one component to the next. So thinking each component in this way, and little kind of soldiers waiting for your orders to take, and they will give you what they know what to do. So in this case, the vector z just knows that to put a number in that z number, in that z allocation. And finally, if you just change this number to, let's say, 150, which is the step, it's going to just jump between 0 to 150 to 300. If I keep growing this, it'll create more and more following that 150. And as you can see, the z component is going to create the same list, always matching data. All right. Now let's make this again 2000, because this is just going to be the height, because we're telling it to move in the z direction. 2000, so this space is going to be 2000, this next one 4000, 6000, as it is in the list. So it's all about data and where you're connecting it and where it's going. Right, next part is going to be extruding those lines, because this is what we're getting now. So as I like to do, I just create a panel and check what information I'm getting. Because we gave it rectangles, which is this rectangle, and this move component is waiting for information to move it. It will take any amount of numbers that you give it in here and move it that same amount. So just create another one. This time I'm going to connect this Z components, and this list is just going to match the amount of this list. The result is going to be rectangles because that's the kind of geometry, but you also have the rest of the information in here, which you can see is just the transform data, and you can see that it moved in these numbers, which again, it will always match the information that you have before. So always keep in mind, information is just moving from one side to the next. Okay, so I'm gonna just clean this up a little bit. So now we have all these rectangles, and I want to extrude those rectangles. So what I do is really simple as always. Type extrude. You can find that one. It's actually not many extrude, but still there's a few extrude options. I recommend you to experiment with those. They have really small details in the way that you use them, and it will take some practice for you to find out what they do. Again, just check what the little icon and the default information they have, and that will give you a clue of how to use them. The most easy to use is this extrude in one direction. This is with that one arrow, because it's just going to ask you for the geometry to extrude, which is normally a curve or a surface, and then the direction. And the same as move, as you can see, is quite similar, just that it has a different letter, but it's asking for the same basic geometry and base geometry with the same geometry icon. Just that in this case it specifies a little bit more, that is asking for a curve or a surface. And then in here is called motion with D, and here is distance, direction, but as you can see it has the same icon, the little black and white arrow, so you can know that even if they have different names, it's asking you for the same information. So it just needs a vector that give it a direction, a distance to move on. And as you can see in here, I just use the same 2000, so it will connect to the same distance that I've given it to move each one of the floors, which is in the series. But in here I'm just connecting one because I want them to move all the same distance, the same 2000. So it's going to take each one of these rectangles and move it 2000. This rectangle again, 2000, and again 2000 and 2000. That's going to take the reference of the rectangle. Something interesting with this component, when you extrude a curve, is going to create a hollow block. It's not going to be a solid. So you can use the component, this little component that I use in here, that is called cap holes. Again, relates to just cap hole. You can experiment with this one, that is with more complex shapes. This is when it's flat shapes. So since I'm working here with cubes, it's quite easy to use that one. And when I turn it on, I'm going to turn this off. You can see that now is solid shapes. All right. Next, what I want to do is to rotate each one of those rectangles, each one of those floors, let's say, and we can use exactly the same component that we had before. It's the same rotation, just that I'm now, instead of connecting the rectangle, the initial shape, I'm now rotating this. And as I mentioned, components are just taking information from behind, and the information is always in there, and everything is connecting. It's all about the relationship between the data and the components that you have and the geometry that you have. In here, I just realized that something got a little mixed up. Let's see what happened. Let's turn this off. Something good to do is just to keep turning on and off things, so you have a clean geometry. In here, let's see what happened. So we have the cap geometry, which is this one, and we have 5 components, 0 to 4, and here it seems it's creating more than that. It's creating 9. Why would that be? Let's see. This is a good way to troubleshoot things. And as you can see, you can go just following back the information, you can find where the problem is. So I just went to the second one, which is angles, and connected a panel and see how many items are in there. And there are 10, but I need to move only 5 elements. That's why at the end is trying to rotate the last one, the fifth item, the index 4 item, all the rest of the time. So let's see what Grasshopper does with this list. So when you have data, remember this is the here. This list is the floors. Let's turn this preview on and off. Each one of this cube is in here. Each one of these elements is each one of this. So this is 0, 1, 2, 3, and 4. And then the rotate command is going to ask me for a number to know how to rotate those. And again, it will try to match the data following that index. So you have to just match the information from anything that is in 0 with anything that is in 0. So 0 is going to rotate 0 degrees, which is connected to this angle. 1 is going to rotate 4 degrees, and so on. 2 is going to rotate 8, 3 is going to rotate 12, 14 is going to rotate 16. But what happens when one of the components have less or more elements than the other one? Well, it will try to just repeat the information with the last component. So in this case, after 4, which is 16, it will just repeat this, the fourth element, the index 4 close berep, which is the last floor. Remember 0, 1, 2, 3, 4, and the first 4 is going to rotate with the same index for 16, and the fifth is going to go again to the 4 index, and 6 is going to jump again 7 to the last one. If we give it an extra one, let's say 6, so now the fifth is going to connect to the fifth, 20 degrees, but it will try to follow along again with the rest of the list. So the fifth, it's going to connect to 6, 7, 8, and 9. So this fifth floor is rotating the fifth 20, 24, 28, 32, and 36, which is what happens in here when I turn this on, turn this off. You can see it's multiple elements on top of each other. So you simply have to make those lists match. Remember, match the data. That's how Grasshopper likes to work. Matching indexes, 0 to 0, 1 to 1, 2 to 2. So in this case, then we have to match the amount of angles to the amount of elements that we have. And what we can do is simply, I'm going to have this, that is the floor number to the count, and make the amount of floors be the same amount. Again, I'm going to use the same slider that I used in here, but I'm going to connect it to this series that goes in here. And in this series, I changed the step to be to go from 0 to the floor rotation, so I can increase this as much as I want. So that series number is going to be then jumping from 4 to 4, whatever number I have in that slider, to the amount of count elements. And as you can see now, is 10 floors, 0 to 9, and 10 angles, 0 to 9. And now that's what the rotate component is going to take, 10 elements and rotate it 10 different times. And that's when you get, again, 10 rotated elements. That's how you get this little rotating tower. And at the beginning you might have all of these sliders a little bit spread all around while you create things. So I recommend you to try to keep these sliders as well organized as possible, trying to move them always to the back so you can find them really quickly. And if you create anything else that is related to the amount of flows, you can just come back and use the same sliders. So everything that you create is going to be connected to the same parameter, in this case number of flows. So now, also if you want to rename things, that if I delete this is the default where you create any slider. Oh, that's not it. It would change to, when you connect any slider, it would change to that name. But if you right click on top of that name and you write here anything, it will change the name of that slider. That's what I did in here. For this one, I just changed it to number of flows, and it's easier to keep track of all of the sliders that you create, that it can get really confusing after a while when you start to create more and more things. And then what it is, just select all of those and right click anything that is empty, and you can group. You can press Ctrl G as well, and that way you can keep things organized a little bit better and easy to follow. Okay, I would say that's gonna be for this video. In the next session, we're gonna work with Ladybug and try to start doing some solo analysis, which I have here, to start experimenting with that a little more and see what you can obtain and how then you can connect this analysis to let generative design help you create more complex and data-informed designs. Okay, until next time, see ya.